Imagine this moment, when we stand within the primordial darkness and witness the Big Bang burst forth. The instant the universe opens its eyes like a colossal newborn crying into existence. This is not merely a scientific question, but a promise to reopen the doorway to the first heartbeat of everything that has ever been. What would unfold before us? Light, chaos, or a beauty beyond all words? Leave a comment and share your thoughts. For this journey begins with curiosity and ends in awe. And then, the question awaits us. Could any living being survive in the face of infinite heat and infinite density? Of all the questions that haunt our understanding of the cosmos, perhaps none is more profound than this. What would it be like to witness the birth of the universe itself, not as a theory in a textbook or a simulation on a screen, but as an unfolding reality, raw, immediate, overwhelming? To stand at the edge of nothing and watch something ignite. To see time itself blink open for the very first time, that is no longer physics alone, but poetry etched in energy. The moment we call time zero is not a second in any traditional sense. It is the absence of seconds, the boundary where existence begins to count but has not yet counted once. Before that instant, there was no before, no place to be, no where to begin from. And yet, from that absence came all that ever was and ever will be: galaxies, stars, atoms, memory, language, love. If we could somehow observe it, if consciousness could float on the edge of becoming and open its eyes to the first flicker of creation, what would we see? Would it be a blast? A detonation across a void? Or would it resemble a great inhalation? A stretch of something soft yet unstoppable? Alan Lightman described it as a silent breathing of space itself, not an explosion but an awakening. And what of the temperature? Words like hot become meaningless here. In the earliest slice of the universe's life, less than a trillionth of a second, old temperatures soared beyond 10 million trillion degrees. Matter and energy were one, indivisible and angry. Density approached infinity, a concept we can write down but cannot truly grasp. If you were there, no known body could survive. No skin could hold. No eye could see. And yet, maybe some form of awareness could drift above the fire, watching not with eyes but with awe. Some physicists like Sean Carroll argue that the Big Bang wasn't a singular point but a boundary condition, a mirror across which time might reflect backwards. If so, then maybe we were never meant to see it, only to sense its consequences echoing forward through time's river. But the mind wonders, if we could observe the zero moment, would we understand the nature of time better? Or would we dissolve into the very paradox we sought to solve? It is tempting to imagine it as a bright flash, a white furnace, but the reality would be stranger. There was no outside to see from, no edge to stand at. Everything expanded from itself. As physicist Jana Levin said, the universe isn't expanding into anything, it's just expanding. A moment without reference points, without coordinates, without distinction. And yet, light did come. Not immediately, for the early universe was a dense soup of plasma, but soon enough. The first photons danced in a fog of charged particles, unable to travel freely until 380,000 years later, when the universe cooled enough for atoms to form and light to fly. But if we were there at the very beginning, before atoms, before time, could we feel the pressure of light unborn? Could we hear the silence before sound? Roger Penrose proposed that what we think of as the Big Bang might not have been unique at all. That perhaps the universe operates in cycles of death and rebirth, eons repeating like cosmic breaths. If true, then our witnessing of the beginning might also be a witnessing of a continuation, a memory wrapped in fire. The laws that governed that first moment, quantum mechanics, general relativity, did not yet cooperate. The unification of forces had not fractured. The symmetry was still whole, a perfect stillness within chaos. It is possible that the very fabric of what would become gravity and electromagnetism was being torn and rewoven before our non-existent eyes. If awareness floated above that tempest, it would not see separation. It would see unity, not as metaphor but as literal truth. There was no up or down, no space between particles, because there were no particles. Just a potentiality erupting into distinction. Just silence blooming into structure. At some point, and no one knows exactly when, the Higgs field turned on, endowing particles with mass like a cosmic dew, settling onto everything that dared to be. Before that, all things moved at light speed, pure energy dancing without resistance, weightless in a weightless world. Then came drag. Then came inertia. And suddenly, there was form. This moment, if moment it can be called, marks the dividing line between dream and matter, between idea and incarnation. To witness it would be to watch reality choose its rules, to see freedom become law, and to know that even chaos must bow to order eventually. But the question remains, if we could stand there, what would we become? Would we melt into the background radiation, swallowed by infinite heat? Or would we be something else entirely, consciousness, without body, presence without boundary? Brian Cox once said that, "We are the cosmos made conscious, and life is the means by which the universe understands itself." Perhaps then, to witness the Big Bang would be less about sight and more about recognition, a remembering of who we've always been. It humbles us to consider that every atom in our bodies was born from that furnace, that the calcium in our bones and the iron in our blood trace their lineage to the instant the stars were made possible. We are not just looking at history when we study cosmology. We are reading our own origin story etched in starlight. So what is the lesson of the 0 second? That from great violence can come structure. From unimaginable heat can come harmony. That what looks like an end might actually be a beginning in disguise. Perhaps this is why we're drawn to these questions. Not to conquer mystery, but to stand beside it. Not to dissect the universe, but to kneel in awe before its unfolding. If this journey stirred something in you, a quiet wonder, a breath held at the edge of everything, then let your voice be part of the story too. Share your thoughts below. Like this video if you believe science can also be sacred. And subscribe if you wish to follow us deeper into the heart of the unknown. Because this was only the first flicker of the match, the first beat of the drum. In the next chapter, we will follow the light as it begins to stretch dimly at first across the newborn canvas of space-time, and ask what it means to see the universe become visible for the very first time. Let us now return to the trembling instant when form and formlessness had not yet separated, when all that would ever be stars and oceans and silence and symphonies was still wound tight within a flicker of possibility. Could the eye of a dreamer glimpse the trembling lattice of quantum foam? That strange, jittering field where energy briefly borrows from nothingness before giving it back. Some believe that in that chaos lay the fingerprints of all structure, tiny wrinkles etched into the fabric of expanding space, guiding the future locations of galaxies like ghostly cartographers plotting their maps in fire. These primordial fluctuations, called anisotropies by physicists, are thought to be responsible for the eventual clumping of matter. But in that first moment, they were only whispers, shadows of a future not yet written. George Smoot, who helped map the cosmic microwave background, once described them as the handwriting of God, a phrase that lingers not for theology, but for its poetry. But what if a human consciousness somehow could perceive these first ripples, not with eyes or ears, but through some deeper sense? Would it feel like standing inside a thought not yet formed, like listening to a song whose first note is stretched across eternity, like touching the breath of time before it exhales? The idea strains the limits of imagination, and that is precisely why it must be followed. For every time we trace the path back toward the Big Bang, we are also tracing inward into the source of awareness itself. What is the shape of origin? And what is the shape of knowing? Perhaps they mirror each other in strange ways we have yet to understand. The expanding cosmos outside may not be separate from the widening reach of inner perception, as if the mind and the universe are co-explorers in a shared unfolding. This idea is echoed by many voices through time. Physicist John Wheeler once said, "We are participants in bringing into being not only the near and here, but the far away and long ago," suggesting that observation is not passive, but part of the very structure of reality, a thread woven into the fabric of becoming. If so, then imagining the early universe is not just fantasy, it is a form of participation, a subtle act of remembrance. Yet still the question remains, what would it feel like to float inside that nascent moment? Not as a camera or a drone or a diagram, but as a witness made of wonder itself. What would the color of nothing be before light learns to scatter? What would silence sound like before vibration has a medium? We often say, the universe began at the Big Bang, but perhaps it always was, waiting for the right kind of attention to bloom. Picture this space as a newborn lake, the surface calm but deep with potential, and then a ripple not from within, but from outside time altogether. That ripple becomes expansion, becomes gravity, becomes hydrogen, becomes stars and bones and breath and memory. And yet the ripple never ends, it is still moving through us now, reaching toward what lies beyond the cosmic horizon. Many cosmologists today believe that the early universe was shaped by a brief moment of inflation, a staggeringly rapid expansion that stretched the quantum fog into a near-uniform sea. Alan Guth, who pioneered this idea, described it as a miracle without a need for divine intervention, a natural unfolding of profound consequence. In his view, inflation smoothed the universe like a potter's hand across wet clay, turning chaos into cosmos. But here's the paradox: if inflation stretched the universe faster than light, then perhaps the very moment of origin is forever hidden from direct view. A veil drawn across the deepest past, one we can infer but never pierce. And yet even that limitation becomes part of the beauty. For what is mystery if not an invitation to look closer? The early universe, then, was not merely a point in time but a condition of being, an orchestration of possibilities collapsing into the real, like a symphony tuning itself before the first note, like a dream that becomes aware it is dreaming, and chooses to awaken as matter. We do not remember it in the way we remember childhood, but perhaps it remembers us, for we are its continuation. And so, we return to the final question in this part of our journey. Did that first trillionth of a second have a shape, a texture, a direction? Or was it all directions at once, all forms and none? A paradox wrapped in radiance. We may never stand there in body but in thought, in wonder, in reverent imagining we already do. Let the mind drift now, like a feather on cosmic wind, not toward answers but toward presence. For the early universe is not only behind us in time, it is within us still, in every electron, every breath, every flicker of curiosity that asks what came before. And in that question lives the same fire that lit the stars, the same mystery that unfolded from the void. And so we drift forward still toward the next horizon of inquiry, where another impossible question glows just beyond the veil, beckoning us onward with silent gravity. Could any being survive the raw violence of that birth moment? Could anything endure the infinite heat and density? Or is survival itself a word too small for such a place? This is where we go next, into the very heart of cosmic fire, into the storm that made all storms possible. Stay close, breathe slow, and follow the shimmer between science and myth, for the universe is about to be born again inside you. What would it look like? The moment light first opened its eyes in a universe that had never known illumination. This question lingers like a whisper through the corridors of cosmology, a gentle tremor in the mind of anyone who has ever stared into the darkness and wondered where the first spark came from. The birth of light was not a scream nor an explosion seen by witnesses. It was a release, a letting go, a soft unbinding of photons that had been trapped for hundreds of thousands of years within a fog of charged particles. And if we try to imagine standing within that ancient moment, we must let go of everything we think we know about vision, color, warmth, and time itself. Before light was free, the universe was a thick plasma ocean, so dense and hot that photons could hardly move a millimeter before, being scattered by electrons like restless birds trapped beneath a stormy sky. Stephen Hawking once said, "The early universe was a seething is less than and hash 0. 5 hash is greater than glowing fog through which light had no path. And in that fog, there was no up or down, no space you could point to, no shape that could hold still long enough to be called real. It was motion wrapped inside motion, a restless womb waiting to cool. Then came the slow unfolding, the cooling, the expansion that stretched the universe wide enough for electrons and protons to finally embrace and form the first hydrogen atoms. This quiet union is the reason we are here, for only when those particles held each other did light find a way to slip past them and journey through the cosmos unbound. Imagine that moment, not as a flash, not as fire, but as a curtain lifting from the stage of existence. Some cosmologists describe it as the universe becoming transparent, like fog evaporating under the first warmth of dawn. But this dawn was not warm. It was vast, almost tender, the glow of a cosmos learning how to breathe. George Smoot once said, "It is like seeing the face of creation." And perhaps he was right, for in that moment, every photon carried the imprint of beginnings. But what would those photons look like to our eyes? Could a human even survive in that primordial scene? The light itself would not kill us, but the universe around us would. Temperatures still thousands of degrees, radiation storms rippling through space like cosmic winds, space not yet cooled enough to allow atoms to settle in peace. we would be unmade in an instant. Our molecules torn apart before the sight even reached our minds. And yet, in a dream of physics rather than biology, we might imagine ourselves hovering beyond harm, protected by an impossible bubble of quantum insulation. Through that impossible window, what would we see? A burning ocean, perhaps. Waves of light rising and falling across a horizon with no land, no sky. Or maybe it would resemble a soft veil, shimmering, weightless, a luminous mist rolling outward in all directions. What colors would greet us? The answer is both simple and profound. At that moment, the universe glowed in a warm orange-red, like the embers of a dying fire, yet filled with the promise of every star that would someday burn. But as the universe expanded, that warm glow stretched, cooled, and softened into the microwaves we detect today. The color we would see now is gone, melted into cosmic distance. Yet the memory of it survives, humming softly in every direction, a quiet music of temperature ripples. This first light was astonishing not because it was bright, but because it was. It marked the universe's transition from chaos to clarity. Before it, nothing could be seen, and more importantly, nothing could see. Vision is a pairing of opposites, light and shadow, presence and absence. And in that first moment, the universe learned the language of contrasts. If we drift gently through that era in our imagination, letting each photon brush against us without harm, we would witness a cosmos settling into symmetry. Tiny fluctuations in temperature, no more than 1 part in 100,000, would flicker like ripples on a still pond. These faint ripples were the fingerprints of destiny, the seeds from which galaxies would eventually grow. A slightly denser patch here, a slightly cooler patch there, and the script of cosmic architecture was written. Imagine drifting through that glowing sea, watching gravity gather its earliest threads, pulling matter into gentle knots, weaving the first hints of structure. The universe was not yet adorned with stars, nor painted with spirals, nor lit by the beating hearts of galaxies. It was young, fragile, a warm cloud waiting for story and shape. And still, through all this unfolding, the light kept drifting, stretching, cooling. It would take 13.8 billion years for those same photons to reach our telescopes, a journey so long that the universe itself changed costume many times before they arrived. Yet when they did, they carried the memory of everything. Carl Sagan once said, "To read the first light is to read the autobiography of the war, cosmos." And in those faint microwaves, in their tiny fluctuations, we found a message written in the oldest language, the language of temperature. It is astonishing to realize that the universe's first light is still around us, passing silently through our bodies, through mountains, oceans, and cities. We do not feel it, yet it is there. So what would it mean to truly see it? Not with instruments, but with awareness. If we let our minds drift into that moment, we might sense the calm after the storm, the quiet clarity that follows the great cooling. The universe was young, and yet in that youth lay the blueprint for all future complexity. Picture yourself floating through this newborn transparency, a traveler not of flesh but of imagination. The light touches you, gentle as breath. You see no stars, no galaxies, only the smooth orange glow filling every direction, serene and total. And slowly, like dawn stretching across an infinite horizon, the glow begins to cool. As time flows, millions of years fold like soft cloth. Gravity deepens its dance, and the first stars ignite. Their light pierces the lingering haze, puncturing the cosmic fog with spears of brilliance. But that is a later chapter, a second birth. The first birth is quieter, more intimate. In that quiet birth, the universe is like a child breathing calmly after a long cry. Its warmth fades, its light softens, but the memory remains. And in that memory, written in the glow of cosmic light, we find ourselves. For we are made of the atoms, forged later in stars. Yet the blueprint for those atoms was sketched in the ripples of the first light. To understand this light is to understand our own first whisper in the cosmic story. And perhaps, in moments of stillness, when the world grows quiet and our thoughts drift outward, we can almost hear it. The soft hum of the universe remembering its first breath. So we return to the question that opened this journey. If a human could stand in that era, shielded from harm, would they witness a burning sea or a gentle veil? Would they see colors familiar or shades that have no names? Would they survive the storm of photons or dissolve into the brilliance that made all future brilliance possible? The answer is simple and eternal. We cannot stand there in body, but we can stand there in wonder. And sometimes, wonder is enough to light the darkness. What would matter look like in its very first breath of form? Not as stars or planets yet, but as mist condensing from the infinite heat of creation. In the seconds after the Big Bang, the universe was no longer a blinding storm of light and energy alone. It was cooling, softening, preparing to become something more than raw fire. As temperatures dropped below 1 billion degrees Kelvin, protons and neutrons, those ancient builders of atoms, began to feel each other's gravity, their dance slowing in the fading roar of expansion. The cosmos in that moment was not silent, but hushed, as if holding its breath. What had once been too hot to form bonds was now fertile with possibility. And in that delicate window, the first atomic nuclei were born. Hydrogen and helium, so simple, so fundamental, emerged not from dust or decay but from pure potential. As physicist Steven Weinberg wrote in the first 3 minutes, the more the universe seems comprehensible, the more it also seems pointless. But perhaps in this moment of gentle structure rising from chaos, it felt anything but pointless. Imagine witnessing it not through the lens of a particle detector, but with the senses of a cosmic traveler drifting just outside time's stream. Would you see matter take shape like fog thickening in morning air, or like embers vanishing into velvet dark? Would you hear a rhythm to it, a heartbeat of formation, as hydrogen nuclei found one another in the cold expanding tide? The birth of matter was not an explosion, but a release. Not a war, but a surrender to order. The union of proton and neutron to form deuterium marked the beginning of all chemistry to come. The first step in a sequence that would one day yield stars, planets, and minds capable of asking how it all began. But could we see that fusion take place? Or would it, pass in a blink too fast to grasp. As cosmologist Alan Guth once mused, the universe is the ultimate free lunch. And perhaps this was the table being set. Atoms arranging themselves without blueprints, only guided by laws deeper than memory. The temperature now dipped below 10 million degrees Kelvin. And in this fading glow, most of the universe's helium was already formed. What followed was silence. For a very long time. Photons still scattered freely, but matter itself had been laid down like seeds waiting in the cold soil of space. The moment of formation was over, but its echo still moves through us. Every cell in your body holds hydrogen born in that moment. Every breath you take includes atoms forged in the quiet after the fire. What then marks the birth of matter, if not color or sound or heat? Perhaps it is structure itself, the way randomness began to ripple with intention, how the universe chose patterns over chaos. It was not a choice made by mind, but by law. And yet it feels like poetry written in particles. In the tapestry of existence, this was the first knot tied, the first thread pulled taut from nothingness to something. Close your eyes and drift back with me. Not millions, but billions of years. Before Earth, before galaxies, before even starlight. We float above a sea of potential, warm but cooling, chaotic but calming. And somewhere in that sea, invisible to eye but etched into all matter since, is the moment the universe took form. Like breath condensing on glass, like dew before dawn, it happened gently. So, what would you see if you could truly witness that turning point? Would it look like creation or like memory? Like something being made, or something being remembered? Because every particle we touch, every element we study, every star we map, was once part of that moment. The cooling universe is not a historical fact. It is a current running through all things still. If you listen closely, maybe you can hear it even now. The long silence after the song of heat. The hush that allowed complexity to bloom. It's not behind us, but beneath us, within us. And as we continue this journey through time and matter, through questions older than stars, one still lingers. Could any living being survive in the face of infinite heat and infinite density? Or is witnessing such a birth forever beyond the reach of those it created? And yet, the silence after fusion was not emptiness, but potential asleep. Imagine drifting through that void not with fear, but with reverence, as if each moment were a sacred pause before another verse of the cosmic poem. There were no galaxies yet, no suns to warm your skin, but there was balance. And in that balance, a promise. Every proton now stable, every helium nucleus formed in just minutes after the birth of time, now floated freely across the expanding sea of space. Matter was no longer in hiding. It had emerged, naked and raw, waiting for gravity to weave it into meaning. We could not see this with eyes, for eyes had not yet evolved. But the universe did not need eyes to continue becoming. So what would it mean to witness this from the outside? To be a consciousness anchored beyond the clock of entropy, simply watching as nothing became something. You would not hear thunder, but you might sense structure forming like a whisper through tension. You would not see stars, But perhaps you'd feel the first shadows being cast where mass began to gather. In that immense quiet, there is a peace deeper than silence, because everything was aligned with law, with inevitability. The particles were not rushing, they were arriving, carried along by the architecture of nature's blueprint. Physicist Sean Carroll once said, "The laws of physics don't distinguish between past and future." And here, in this moment, the truth shimmered without contradiction. Imagine walking through this landscape not with feet, but with thought, with wonder as your guide. You would pass hydrogen atoms like drifting embers of destiny, untouched by time. You might see the faint murmur of gravity starting its slow work, 1 billion years before stars would blaze into being. It would feel like a memory and a prophecy woven into one fabric. The cooling did not stop. It deepened, and the universe stretched like a breath held too long. What had been a firestorm of light now glowed dimly with the background radiation we can still detect today. This afterglow is the echo of that time, still whispering through our radio telescopes, still telling us that the beginning never really ended. You are made of these atoms. Their birth was your birth. When matter cooled, it left a trail, and you are part of that trail. You are not a visitor to the universe. You are the universe aware of itself. So when we speak of the cooling universe, we are speaking also of the moment consciousness became possible. Not in that instant, of course, but the seeds were sown. Without stable matter, there would be no stars, and without stars, no planets, and without planets, no liquid water, and without water, no chemistry complex enough to dream of time. This is why the cooling of the universe is not merely a change in temperature. It is a transformation of meaning, a shift from randomness to relationship. The particles no longer moved like strangers. They began to orbit each other, to feel each other's presence, to respond. What was once chaos was now choreography. The question then becomes, how can we know when matter truly began, when there was no observer to mark the hour? The answer may lie not in the timeline, but in the signatures left behind. The cosmic microwave background is one such signature, faint but persistent, a soft hum beneath all creation. And there are others, ratios of elements etched into the interstellar medium, tiny balances between hydrogen, helium, and lithium that match predictions from those first fleeting minutes. These are not guesses, they are relics, fingerprints left on the table of time. In them, we do not just find data, we find intimacy with the cosmos, a relationship between question and answer, between observer and origin. As the great Carl Sagan said, we are a way for the universe to know itself, and in that, knowing lies the beauty of the cooling era, because it made memory possible, and imagination, and science itself. Not immediately, but inevitably, like a symphony beginning in silence, where the first notes are not heard but felt in the chest. So here we float still, in a cooled universe, but not a cold one, warmed by stars, by thought, by the breath of curiosity that never stopped flowing from that first moment. And if we were to witness it again in some future echo, some cyclical rebirth of cosmos, we might, not fear the heat or the chaos, but greet it as the beginning of the next great becoming. Could any living being survive such extremes? Infinite temperature, infinite pressure, infinite light. Likely not in body, but perhaps in awareness, in presence. In the simple act of asking the question, we become part of the answer, woven back into the story from which all stories come. When did the universe go from opaque to transparent? When did light finally break free from its prison of plasma and begin its eternal journey across the cosmos? And if we had been there watching in silent awe, could we have seen that very moment when the cosmos revealed itself for the first time? The story of the first atoms is not merely a chapter in cosmology, it is a turning point where the universe transformed from a stormy sea of chaos into something that could breathe light and form stars and give birth to the elements of life itself. Before this threshold was crossed, the cosmos was a blinding mist of energy and particles in constant collision. Photons endlessly scattered by free electrons in a dense plasma fog. It was not a universe of galaxies and stars, but of motion and murkiness. A place where vision was meaningless because no light could travel far before being deflected again and again. And then quietly, almost like a breath being held, the temperature dropped, the plasma cooled, and for the first time, protons captured electrons and formed neutral hydrogen atoms. That was the moment everything changed. Light was freed from its ancient shackles and began streaming outward in every direction, leaving behind a glowing echo, the cosmic microwave background, or CMB. George Smoot once described this moment as like seeing the face of God, while Stephen Hawking called it the discovery of the century, if not of all time. This invisible light has been traveling ever since, stretched by the expansion of the universe, cooled to a near whisper, and yet it still surrounds us. We walk through it every day, bathed in this ancient relic of creation without even knowing. It is not just radiation, it is memory made visible. The record of a universe that finally became transparent to itself. What marked that boundary between the plasma age and the age of light? It was a moment known as recombination, though the name is misleading. There was no combining again, but rather the first stable joining of matter and structure. And in that act of cosmic stillness, the firestorm quieted into clarity. It took nearly 380,000 years after the Big Bang for this to happen. But from the scale of the universe, that was merely the blink of a newborn eye. If we had been observers in that moment, drifting in the void like silent witnesses, we would not have seen bright flames or exploding stars. Instead, we would have seen a gentle glow fading into shadow, a universe no longer ablaze, but glowing like an ember wrapped in silence. And then, the silence would deepen, for after light was released, darkness would again reign until the first stars began to shine hundreds of millions of years later. Max Tegmark once said, "Our eyes see only a tiny fraction of what light has to tell us. The real beauty of the universe lies in what we cannot see." And indeed, the wall of light, the surface of last scattering, lies so far in time and space that we can only observe it through instruments like the Planck satellite or the Wilkinson microwave anisotropy probe. But if we could see with perfect vision across time, we would see that wall not as solid, but as the soft edge of a dream finally waking up. This boundary is what defines our observable universe. The farthest light that has had time to reach us since the beginning. Beyond it, we cannot see, not because there is nothing, but because light has not had enough time to arrive. It is a horizon not of space, but of time itself. and this horizon expands every second as the universe continues to unfold. How profound that the atoms which first made transparency possible would one day form galaxies, stars, planets, and even us. That, from a fog of hydrogen and helium, the universe learned how to shape memory, mind, and meaning. In a sense, the moment atoms formed was not just a physical transformation, it was a spiritual one. The cosmos became legible to itself, and the great story of light and shadow could finally begin. So we ask again, when did the universe become transparent? The answer lies in a hush that settled across space when energy slowed enough to let structure hold. It lies in the faint whispers of microwave light that still echo through every corner of existence. And it lies in us beings made of atoms that remember their birth in silence and fire. To see that moment would be to see the cosmos shedding its veil for the first time. To witness the great reveal, not with sound and fury, but with a shimmer and a hush. And in that hush, we would feel the heartbeat of everything to come. Perhaps we already do. In dreams, in awe, in the stillness between thoughts. Let us then keep listening to the silence between stars. Keep looking for the light that never stopped traveling. Keep remembering that we are made of atoms born from a moment the universe chose to let itself be seen. And perhaps, as we fall asleep under ancient skies, we are not just remembering that moment but reliving it. Every breath a soft echo of that first light. Every heartbeat a ripple from a wall of light older than time itself. What would it feel like to drift through the early universe? Before the first star was born, before even a single photon had broken free from the plasma mist. Could we witness the very beginning of structure in the cosmos, not the blazing birth of suns or the elegance of spiral galaxies, but the subtle choreography of invisible mass shaping space itself? Would we see anything at all? Or would the darkness remain silent, undisturbed, hiding its blueprints in folds of gravity and time? The story begins not in fire but in silence. A silence older than memory, older than light. In this silence, after the initial burst of the Big Bang, the universe cooled just enough for matter to settle, but not enough for light to escape. And in that heavy darkness, something profound began to unfold. Long before stars lit the sky, long before galaxies spun their silver spirals through the night, the first patterns were drawn by something unseen: dark matter. Vera Rubin once said, "We see the effects of dark matter, but not dark matter itself. It is the silent architect of the cosmos. It neither emits light nor absorbs it, but it shapes everything that does." Dark matter did not need to glow to matter. It needed only to exist, to gather, to curve the very space around it. As the universe expanded, dark matter began to cluster very slightly at first, responding only to the pull of its own gravity. It formed filaments and knots like threads of tension in a vast and invisible web. The physicist Carlos Frenk described it beautifully. The universe is not chaotic, but structured thanks to dark matter's guiding hand. Through simulations and observations of gravitational lensing, we've glimpsed the shape of this scaffolding, an enormous skeleton upon which visible matter would later gather like flesh. Stars would form in the intersections of this web. Galaxies would swirl around its anchors. But what if we could be there not as scientists in laboratories, but as witnesses drifting silently through that ancient night? What would it feel like to see the first ripples condense into meaning? Would we see the seeds of galaxies falling into place, or would all appear as swirling shadows in a fog of silence? In that darkness, there was no up or down, no light to cast a frame of reference. And yet, direction emerged from the pull of gravity itself. Invisible rivers flowed through nothingness, and matter obeyed. These seeds, as cosmologists call them, were tiny fluctuations in density, echoes of quantum tremors stretched large by inflation in the earliest instance of time. Each seed a potential galaxy, a whisper of structure. But was this structure something we could truly observe? Or did it belong to a scale so vast, so quiet, it could only be felt in the slow patience of evolution? Could the mere act of observation, across time, change what we witness, or is this process immutable, unbothered by our gaze? Some physicists point to the paradox of quantum measurement, how particles behave differently when watched. Could the cosmic web, too, respond to awareness? Not in mechanics perhaps, but in meaning. Are we not just watching the structure form, but also participating in its unfolding by seeking it? This isn't merely a scientific inquiry, it is philosophical, spiritual, perhaps even poetic. The universe did not begin with clarity, but with gradients. Not with shapes, but with tendencies. Preferences for curvature, for convergence, for complexity to arise from the simple pull of mass. In the void, dark matter played the first note. And from that note came a melody, a structure built not from light, but from silence, bending space itself. And that raises a second question. What role does dark matter truly play in the birth of structure? If it never shines, why does it define so much of what we see? Because it is the invisible current beneath the visible ocean, guiding waves, shaping destinies. It was dark matter halos that caught the drifting gas, that allowed it to cool and collapse, that gave rise to the stars and galaxies we now know. Without it, matter would have remained smooth, spread thin, without story, without form. Astrophysicist Jeremiah Ostriker once said, "Dark matter is the shadow that determines the shape of the light." A poetic truth that echoes through every galaxy's spiral, every cluster's core, every echo of the cosmic microwave background. But here's the final and perhaps most delicate question. If we had eyes capable of seeing this silent dance from its beginning, if we could observe structure forming from the inside, would the very act of watching alter the pattern? Would the web shift? Would it pause for our attention? Or would it continue unfolding as if we were never there? Some believe that observation is interaction, that nothing is passive in a universe where everything affects everything else. Even light bends when near mass. Could thought, then, bend meaning in a similar way? It is a tender mystery, one that science may not resolve, but that wonder can cradle nonetheless. We are not merely watching the universe unfold, we are part of its unfolding, woven into the same threads that link dark matter to galaxies and galaxies to thought. And so we return, always return, to the darkness, not to escape the light, but to understand where light was born, in what shape it was first cradled, in what web it found a home. To see the first structures form is to witness silence become architecture, darkness become destiny, absence become a canvas for everything that came after. The cosmic web remains unseen to our eyes, but not to our minds. We feel its presence in the distribution of galaxies, in the cold spots of the CMB, in the way the night sky refuses randomness. There is pattern even in the dark. And if there is pattern, there is meaning. And if there is meaning, then perhaps there is something deeper still, something waiting to be known by beings made of stardust and longing. If you've ever looked into a clear night sky and felt something stir, not fear, not confusion, but a quiet knowing, then perhaps you, too, have brushed against that ancient structure. Not with sight, but with presence. The first structures in the darkness are not gone. They are beneath us, around us, within us. Their memory hums in every atom of your body. Their gravity still pulls us home. If this touched you, share what you imagine we'd see in that early darkness. Comment below. Would it be a chaos of swirling shadows, or a harmony of structure already beginning to sing? What would it feel like to witness the first star ignite in a universe still wrapped in its newborn darkness? Would the moment arrive like a sudden flame tearing through the silence? Or would it be a quiet blossoming of light, delicate as a flower unfolding at dawn? When we imagine the first star of the cosmos, we imagine a fire that was not merely bright but sacred. A fire that carried within it the destiny of every world that would one day awaken under its descendants. Before this light existed, the cosmos was an ocean of cooling gases, a dim expanse where hydrogen and helium drifted like lost memories searching for meaning. Nothing shimmered, nothing burned, nothing broke the monotony of the cosmic night except the slow widening of space itself. Astronomers call this era the Cosmic Dark Ages, a phrase that feels almost poetic, as though the universe was a wandering soul awaiting the spark of consciousness. And into this endless quiet, gravity whispered a different future. The first stars, what we now call population, E-third stars, were born from these whispers. Their formation was not explosive but inevitable. Gravity gathered the drifting gases in vast clouds, drew them together, squeezed them with an invisible patience that lasted millions upon millions of years. Deep in these clouds, pressure rose, temperature rose, and the heart of a star began to beat long before it shone. When fusion finally ignited, it was like the cosmos inhaled for the first time. Volker Brom said, "The first stars were the lights that ended the cosmic dark ages, the beacons that told the universe it was time to grow up." And there is a quiet truth in this, because when the first star flared to life, it was not just illuminating space, it was illuminating possibility. The darkness was no longer eternal. It had been challenged. But to ask what the first star looked like is also to ask what it meant, for these stars were unlike any that came after. They contained no metals, no carbon, no iron, no heavy elements that today allow stars to cool more efficiently, is less than unknown, is greater than. They were pure, made only of the primordial materials born seconds after the Big Bang. This purity made them different in behavior, in shape, in brilliance. Some were hundreds of times more massive than our Sun, perhaps even more. Their cores burned hotter and faster than any star we can see today, turning hydrogen into helium at a pace that seemed almost frantic. Because of this burning hunger, they lived short lives. 1,000,000 years. Maybe 2. No more. A fleeting candle compared to our Sun's calm 10 billion year journey. And this invites the question that falls over the mind like a soft shadow. Could any living observer ever behold the full life of such a star, from ignition to collapse? Could a consciousness exist for long enough to watch a cosmic giant blaze into being, swell with its own radiance, and die in a supernova that sprayed the first metals across space? Or is the spectacle forever lost to us, confined to theory, imagination, and the faint signatures hidden in ancient starlight? Carl Sagan once said, "We are made of star stuff," a line often repeated, yet never more applicable than here. For the deaths of population 3 stars seeded the universe with the elements of life. Without them, there would be no planets, no oceans, no trees, no breath. Their sacrifice shaped the future, and in that sense we are not their observers, we are their descendants. Still, another question lingers like mist around starlight. Did these first stars illuminate the universe broadly? Or did they shine alone? Tiny lighthouses in a sea of darkness. Dr. Anna Frebel remarked, "The first stars were lonely. They lived in a universe not yet ready for company. Perhaps their light did not create a grand cosmic dawn, but rather small sanctuaries of brightness, isolated oases of fire, blazing valiantly against the overwhelming cold. Even now, we have never seen one directly. Their era lies too far beyond the reach of current telescopes, too ancient, too faint. Yet their fingerprints remain, etched in the compositions of younger stars, and in the subtle patterns of the cosmic microwave background. It is like hearing a melody from an instrument long vanished, the notes echoing through time even though the musician is gone. The James Webb Space Telescope stretches its golden mirrors toward this mystery, trying to grasp the faint glow of ancient galaxies that may contain the last whispers of these stellar pioneers. Perhaps one day, we will see their afterglow, a ghost of light traveling across 13 billion years of space, reaching our eyes like a message from the beginning of time. If we could float in that early universe, if we could drift silently in the blackness before the first star's fire, what would the moment of ignition feel like? Would it be a trembling on the edge of perception, a soft warmth spreading through the void? Or would it erupt like a roar against the stillness, the way a single spark in a cave can change the shape of the entire night? The first star did not merely shine, it declared itself. It told the universe that light was possible, that structure was possible, that future was possible. In its fire, the cosmos found direction. In its death, the cosmos found diversity. To imagine this moment is to imagine our own beginning. For the atoms in our bones were forged in those ancient furnaces. The oxygen in our breath was shaped by their explosions. The calcium in our teeth was born from their ashes. We do not observe them from the outside. We remember them from within. So, as we drift through the night, wrapped in the soft glow of familiar stars, we can ask a final question that hangs in the stillness like a lantern. Could we ever witness such a genesis again? Could another first star ignite, somewhere beyond our cosmic horizon, in a pocket of space we have not yet reached? Or are we living in the only dawn the universe will ever know? And if another dawn awaits, perhaps far from here, perhaps in a universe beyond our own, would a watcher there ask the same questions we ask now? Would they look into the newly lit sky and feel the same wonder, the same quiet trembling of awe, the same instinct that whispers that light is not merely seen but felt? Because when the first star was born, the universe did not just brighten, it awakened. And perhaps, somewhere, in some distant realm of existence, it will awaken again. Of all the chapters in the life of our universe, one of the most turbulent yet poetic was the birth of the first galaxies. But what did they look like? What did they sound like? And if we had been there adrift in the cosmic sea, would we have seen form emerging from chaos, or chaos pretending to be form? Galaxies are the fossils of structure formation, says astrophysicist Sandra Faber. But these early fossils are not quiet stones buried in time. They are blazing tempests of matter and motion. The earliest galaxies, she continues, were wild places, untamed and molten with the memory of their violent creation. So let us begin here with a question that reaches across light years and into the very soul of cosmic memory. When the first galaxies spun themselves into being, were they more chaotic than the galaxies we know today? The answer hides in the silence between stars, in the faint glimmers now reaching us from over 13 billion years ago. And the images we've seen thanks to James Webb and its deep golden gaze show us galaxies twisted like ribbons of starlight, clumped, and stretched in shapes that seem more like music than mathematics. These were not the grand spirals we sketch in textbooks or the neat ellipses in diagrams. They were messy, fragmented, still forming from the interstellar storms of hydrogen and dark matter. The gravity pulling them together was not delicate. It was brutal. It was raw. Galaxies did not emerge like flowers blooming in spring. They were more like whirlpools of cosmic dust spinning themselves into being by sheer force of collapse. And if someone or something could have floated there in the ancient dark and watched them rise, what would they have seen? Would they have recognized these primordial structures as galaxies at all? Or would they have seen light and shadow weaving like dream threads across an infant sky? Imagine watching two proto-galaxies merge in real time, said Professor Richard Bouwens from Leiden Observatory. You'd witness a slow-motion collision that takes hundreds of millions of years, but from our perspective it's only a frozen snapshot. But what if time wasn't frozen? What if you could walk among these, forming titans as they slammed into one another? Not with explosions, but with tidal embraces that pulled stars into spirals and bent halos of matter like waves in an invisible ocean. The question arises naturally, could an observer in that era witness a galactic merger unfolding before their eyes? Theoretically, yes, if such an observer could survive the gravitational tides and the radiation storms. They would see one of the most majestic ballets in the universe. Not choreographed, but instinctual gravity's pure language, written in spirals and bridges of stars. Even now, in the modern sky, we see remnants of those dances. The tadpole galaxy, with its tail of torn stars trailing behind like a comet's memory. The antennae galaxies, locked in an embrace that has lasted longer than human history itself. But back then in the early universe, such collisions were not rare. They were the rule, not the exception. And yet the real mystery emerges not from what these galaxies did, but when they did it. Why are some galaxies appearing too early, too massive, too evolved for our standard models to explain? We expected to see baby galaxies at high redshift, said Garth Illingworth, one of the pioneers of early galaxy surveys. But what we found were adults in the nursery. This revelation has shaken cosmology in recent years. James Webb has peered deeper than any telescope before it. And what it found in the earliest epochs was not chaos, slowly learning order, but complexity blooming almost instantly. Galaxies like GNZ 11 or JADIS GSC 13-0 seem too mature, too heavy, too luminous for their cosmic age of just a few 100 million years. How could structures that large and luminous emerge so quickly after the Big Bang? What engine accelerated their birth? Are we missing some ingredient in the early universe's recipe, a catalyst we have yet to understand? Perhaps there were seeds planted earlier than we thought. Black holes growing faster than our theories allow. Dark matter scaffolding more efficient than expected. Or inflation itself leaving behind ripples strong enough to fold matter rapidly into stars and galaxies. The mystery deepens because every observation is a look back in time. And the light we receive now is not just illumination, it's a whisper from a universe that was already surprising itself. But perhaps the real question is not how but why we are here to see it. Of all the epochs in cosmic history, this one now gives us the tools to witness what was once invisible, to question what was once accepted, to imagine what was once unimaginable. To watch galaxies form is to watch time itself gather shape. For these spinning islands of light are not merely collections of stars. They are clocks made of gravity and fusion and memory. And as we look back to those early galaxies with instruments that stretch human sight across billions of light years, we are not just observing astrophysics. We are touching a mirror of our own origins. For every spiral, arm we see twisting in that young light, every burst of starlight born from hydrogen's quiet flame, echoes in the atoms of our bodies, in the calcium of our bones, in the iron of our blood. We are made of ancient stars, and those stars were born in galaxies that dared to form when the universe was still a child. So when we ask, were early galaxies more chaotic than today's? Could someone have watched them merge? Why did they appear too soon? We are not just studying distant light. We are searching for the hidden verses in our own cosmic poem. As Carl Sagan once said, some part of our being knows this is where we came from. And now we ask again, as galaxies rise from ancient darkness into our present understanding, what else is waiting to be found? Not just in the stars above, but in the questions we dare to ask when the universe sings its oldest songs. Close your eyes. Feel the rhythm of those early galaxies turning slowly through time, and let their mystery carry you to sleep or to wonder. The galaxies are still spinning, and the questions have only just begun. Where does the universe go when it grows older? Can space itself wrinkle with time like skin that once stretched taut, now slackens in the quiet breath between galaxies? Is the cosmos still singing its song of creation, or has it begun to hum a deeper tune, slower, wiser, almost solemn? We often ask how the universe began, but rarely do we ask how it matures. And yet that might be the more human question, not birth, not death, but the life in between. A life that stretches across eons like starlight on the sea of time. A life where chaos crystallizes into stars, where galaxies swirl like aging dancers on a stage of silence. In the words of the physicist Brian Greene, we are not simply in the universe, we are the universe. And if we are the universe, then perhaps we too are growing old alongside it. There's a whisper in the fabric of space that says not all things stay the same. That even the constants we thought eternal, the gravitational pull, the speed of light, the cosmological constant itself, might bend ever so slightly over time. So gentle a drift that no eye could see it, no ear could hear it. But like the tides, its rhythm changes everything. If you could float above the universe and watch it over billions of years in a time-lapse ballet, would you notice the expansion slowing or accelerating? Would dark energy push harder or ease its grip? Would space-time fray like cloth worn thin by the hands of time? Or would it remain seamless, an illusion of perfection stretched across dimensions we barely understand? The evolution of the cosmos is not a single story but a symphony of changes, silent, shifts in the way gravity speaks to matter, in how clusters form and drift apart, in how the light from the first stars fades into the long dusk of a cooling sky. We do not see it because we are brief creatures, candles lit for moments against the dark tide of deep time. And yet we wonder, If we could live long enough, or see far enough, could we witness the universe grow? Not just in space, but in wisdom, in structure, in story. Would we see the emergence of order from the symphony of entropy, the rise of complexity from the bedrock of randomness? Cosmic evolution is not simply about the galaxies we see on telescopes or the stars we chart in night skies. It's about what patterns emerge when time becomes deep and matter becomes wise. It's about the universe learning how to build itself, from dust to atoms to cells to minds that ask questions like this one. Carl Sagan once said, "We are a way for the cosmos to know itself." And in that reflection is a truth that burns quietly behind every star, that to witness evolution is to participate in it. That our thoughts, our dreams, our stories of galaxies and beginnings and ends are not separate from the universe but echoes of its unfolding logic. So what if the constants shift slowly, like tectonic plates of truth under the oceans of reality? What if gravity pulls a little softer than it once did? What if time itself breathes differently in the folds of expanding space? These are not merely theoretical questions, but invitations to humility, to see ourselves not as rulers of nature, but as guests at a table laid by the stars. If the universe is still growing, then so are we. And perhaps that's the quiet miracle, that we can even ask such questions at all. That a being made of dust and memory can look into the void and wonder not just what is, but what is becoming. The shape of space may not be visible to the naked eye, but the curvature of destiny is written across every spectrum we measure. The cosmic web, a lattice of dark matter and light, pulses with a kind of heartbeat, slow and vast and full of silence. Its filaments stretch not just across light years but across ideas, of order emerging from fire, of galaxies as neurons in a mind, too large to name. The astrophysicist Sean Carroll said, "The arrow of time is a feature of the universe that points from low entropy to high." And in that rise of entropy lies the map of evolution, not toward decay, but toward complexity. Toward the strange possibility that out of randomness comes meaning. Can we see it with our eyes? Perhaps not. But the instruments we build, the telescopes that drink the light of ancient stars, are extensions of those eyes, crafted not of flesh but of purpose. They show us a cosmos in motion, a tapestry being woven still, thread by thread, light by light. Is it possible to witness the shift from chaos to order? Can a mind trace the arc of complexity from hydrogen to humanity? These are questions not just of science, but of soul. For to watch the universe evolve is to glimpse something divine in the unfolding of dust, a kind of sacred geometry etched into the structure of everything. We do not see edges or borders in space, but we feel the boundaries of understanding stretch with every new discovery. The laws we once held sacred buckle slightly under the weight of precision, like old maps redrawn as explorers reach new coasts. And still the questions remain, not as flaws in our reasoning, but as music still playing, asking us to listen more deeply, to feel the resonance of the stars not as cold fires but as messages, as invitations. If you could walk across space-time like a garden, feel the grass of gravity beneath your feet, would you notice where it thickens, where the air of expansion grows thinner, where the hum of dark energy gets louder or more still? Perhaps not with eyes, but with wonder. And so we return to the question that opened this dream. Can a person sense the aging of the universe? Is it too slow for us, or too vast to measure? The answer may not lie in equations but in presence, in our willingness to look up and listen and wait. We are the children of stars, and like any child, we age, we learn, we ask harder questions as we grow. Perhaps the universe does too. Perhaps the laws that shaped galaxies now shape questions within us, questions of meaning, direction, destiny. And perhaps the ultimate act of cosmic evolution is not the birth of stars, but the birth of understanding. If you felt the pull of that question, the quiet gravity of curiosity, leave your thoughts below. Share the voice of your own stardust, for we are still evolving. And who knows, maybe one day our descendants will see the answer painted in the sky. Not in words, but in light. Keep wondering, for the universe is not finished yet, and neither are we. What if the Big Bang was never the beginning at all? What if that brilliant surge of light and time was not a singular spark from nothingness, but only the crest of an eternal rhythm, a breath taken in a cosmic sleep and exhaled again into stars? Across the fabric of ancient texts and modern physics, one whisper repeats itself like a hymn, that perhaps the universe is not a line with a start and an end, but a circle dancing quietly beyond the grasp of clocks and calendars. As physicist Sir Roger Penrose proposed in his theory of conformal cyclic cosmology, the universe might have gone through infinite cycles of expansion and contraction, each Big Bang not a beginning but a transformation. And so we wonder, if we could stand at the very edge of the first light, if we could witness the Big Bang not as a textbook diagram but as a living moment, what would we truly see? Would the explosion roar like divine thunder across a void? Or would it pulse softly like the breath of something that never truly slept? The questions grow darker as we look deeper into the light. Was there a universe before this one? Folding inward, collapsing upon itself like a great lung at rest, waiting to exhale once more into being? Or was it all born in a singular instant, not from something else, but from a rule we have yet to understand, a law deeper than cause and effect? The Indian Vedas speak of kalpas, vast cycles of creation and dissolution, where the universe is dreamed and dissolved by Brahma in eons beyond counting. In the West, Poincaré once mused that eternal recurrence was not a philosophy but a mathematical inevitability in an infinite cosmos. Science now peers into the early plasma of our universe and finds anomalies it cannot explain, symmetries where none should exist, alignments that echo across billions of light years. Is this coincidence? Or a fingerprint of memory? Scars from a past cycle lingering in the present fabric of space? Astronomer Laura Massini Houghton once proposed that the cold spot in the cosmic microwave background might be evidence of a previous universe bleeding into our own, a shadow of a world before time. And so the idea emerges not as myth but as possibility, that time itself may be curved, that beginnings are illusions shaped by our need for linear stories, that the cosmos has no true origin, only transitions. If we were there, at that first burst of brilliance, would we hear the echoes of collapse before the rise? Would we see the implosion behind, the explosion, like breath before voice? Physicist Neil Turok says, "We think the Big Bang was the beginning of time, but it may be just a bounce from a previous universe that collapsed into itself before expanding again." What a thought, that we are not children of a miracle once, but descendants of infinite awakenings. To witness the Big Bang would be to witness not birth, but a passing of the flame from one cosmic chapter to the next, a great relay across eternity. It would not be chaos exploding from nothing, but rhythm unfolding, an orchestra tuning between movements. And what would it feel like to be there, to watch time begin again, and to suspect it had happened many times before? Would the light feel familiar, like the warmth of an old sun remembered in a new dawn? Would the sound resemble a chant sung once too often to forget? In such a moment, awe and terror would blend into silence. There would be no words, only sensation, as the vacuum cracked and time poured forth like golden floodwaters over an ancient plain. Perhaps matter would emerge not from nothing, but from compression, like diamonds formed in the collapse of older stars, a kind of cosmic alchemy passing memory through pressure. And we, the witnesses, would stand not outside the story but within its turning pages, ourselves made of cycles and echoes. What if consciousness itself is part of that rhythm, awakening in each universe anew, never remembering but always yearning? What if your curiosity, the very urge to ask this question, is a whisper from before time, echoing back to itself across the vastness? There is poetry in physics when seen not as a mechanism but a melody, and the Big Bang is perhaps its most beautiful refrain. But no refrain exists without what comes before it, and what follows after. So we must ask, what created the moment of becoming itself? Randomness, or a hidden architecture of cycles so vast that even eternity bends before them? In the words of Carl Sagan, the cosmos is within us. We are made of star stuff. We are a way for the universe to know itself. But maybe it's not only to know, maybe it's to remember. The Big Bang may not be an exclamation point, but a comma, in a sentence the universe has spoken countless times before. To witness it would be to catch the universe mid-sentence, to feel the breath between syllables, to realize that we have arrived not at the beginning, but at the continuation. In every nova that dies, in every galaxy that drifts into silence, we see hints of this cyclic truth, that what ends begins again, not in defiance, but in design. Some physicists believe the cosmological constant could be shifting slowly, hinting at a future contraction, a big crunch that may lead once more to a big bounce. If so, then this isn't just about the past, but the future. A vision of time folding in upon itself like the petals of an eternal bloom. And if that is true, then the next Big Bang awaits not behind us, but ahead, a cosmic sunrise yet to come, the next breath of the universe already forming in the silence of deep time. We may be children not of a single light, but of a flickering lamp, carried through the corridors of forever, one flame passed from shadow to star and back again. And so the question remains, as we gaze at the stars and wonder who we are, was there truly a beginning? Or have we always been dancing in a circle of fire and forgetting? If you believe that the universe may still hold echoes of its past lives, if you feel there's more to this rhythm than just chance, then share your thoughts below. Could it be that what we call the Big Bang is simply the memory of a heartbeat before time itself was born?